Hi guys, if this kind of question appears in the final GENCO chemistry exam, how you will attempt this? So let's see. So here the question is a titration graph between a metal-ion and a mono bi-tetradentate ligands individually shown here. Then which curve is followed by a bidentate? So they have given three different curves in a graph. Okay, they are asking what is the curve that follows a titration between a bidentate ligand against a metal. సో మెటల్ అయాన్కి బైడెంటెడ్ లిగెండ్ మధ్యలో వచ్చిన కర్వ్ ని మీరు ఐడెంటిఫై చేయాలి. ఇస్ ఇట్ క్లియర్? రైట్. సో బిఫోర్ explaining this, I will tell you some basic idea. Suppose you are dealing with a metal with monodentate ligand. So it will form a metal complex, isn't it? Metal with monodentate ligand. Say its rate constant is K1. Now the same metal ion, now it is reacting with a bidentate ligand. So it will form a metal bidentate ligand. Its rate constant is somewhere. Okay. The same metal ion now reacts with a tetradentate ligand and it will form a metal with a tetradentate ligand. Its rate constant is K. So now tell me which of these values are more. When you compare K1, K2, K3, K3 value is maximum compared to the K2 and K1. The reason is when a ligand donates more number of atoms to the central metal ion, like this, it will form a chelating compound. Chelation means ring formation takes place. When the ligands are ring forming with the central metal ion, their rate constants will be maximum. So if you observe this graph now, look at the graph here. Here the endpoint is starting now like this. So there is a large break. There is a large break in the endpoint region for curve A. That means its rate constant is maximum. So it might be K3. The break is very bigger if you see from here to here. This at the endpoint region, the break is maximum. That indicates the formed compound is highly stable. Now look at B. B is going like this. It's a break point up to here, to histamine. So it is slightly lesser than the K3. So you can say that this B curve indicates K2. That means it is a bidentate ligand curve. So this is a question they are asking. Now, what about C? The break point is not there. That means its rate constant is very, very, very less. The formed compound with the monodentate ligand, its stability is very less compared to the remaining two. So that's why there is no equivalent point in this. If you observe, there is no equivalent point. That means the formed compound stability is less. So this is how they will frame questions on graphs related to the titration with the metal. Okay. So what is your answer in this question? So which curve indicates the curve indicates between a metal ion and bidentate ligand? It is curve B. So this is your answer. Suppose if you are extending the discussion further, the metal ion with the EDTA titration. So what is the value? Say if I say it is K4, what could be the value of K4? Is it lesser than K3 or greater than K3? It must be greater than K3 and other values. So what could be the graph of EDTA metal? So it will go beyond this line, right? Beyond this line. So this indicates EDTA ligand with metal titration. That means it is having even more stable compared to the tetradentate ligand. What could be the reason for that? Because EDTA at a time donates 6 ligands to the central metal ion. So it will form a octahedral complex, isn't it? So it is more stable compared to tetrahedral or square planar complexes. So that's the reason why metals with EDTA is giving you a more stable complex. So now, what is this 1:1, 2:1, and 4:1? So here, this 1:1 indicates that the central, say this is the ligand on ratio with the metal ion. That 1:1 indicates, okay, 1:1 indicates that one ligand is binding with one metal ion. And here 2:1 indicates that two ligands are binding with the one metal ion. 4:1 indicates four ligands are binding with the one metal ion. So this is what the ratio indicates. So here 1:1 type are more stable compared to 2:1 and 4:1. So the break point is important. With the help of the break point, you can easily decide which type of ligand the curve indicates. So if it is a bidentate, it is B. If it is a monodentate, it is C. If it is a tetradentate, it is A. So EDTA, I said EDTA may takes from here like this. That is also 1:1 type, but its stability constant is much more bigger than the tetrahedral. So this is how you have to attend. For more such videos and full content of analytical chemistry, click the link in the description. Hope you enjoyed this. Thank you all.